Our universe is a fascinating place. It is made up of a number of planets revolving in their own respective planetary systems, in the respective galaxies. Many stars, celestial bodies, planets make up our galaxy, revolving around a massive black hole at the center. That's the bigger picture. But have you ever thought of the smaller one? Hello, cyber citizens. Welcome to What the Science, the channel where curiosity meets science. This is the first episode of our mini-series, Understanding Universe. This episode will cover what is universe made up of at the fundamental level, the four fundamental forces that govern the universe, and the quantum field theory. So without further ado, let's get started. From the beginning of humanity, some or the other individual wondered about the makeup of universe. This question of what is universe made up of led to a number of inventions and scientific discoveries. To find the proper answer to this question, we started analyzing the matter deeper and deeper until we found out it is made up of tiny indivisible particles called an atom. This idea came to the researchers back then by a simple idea that if you go on cutting a matter smaller and smaller, a point will come when you can't cut it further, but we wanted to know more. So we went inside an atom to find out that they are made up of neutron, proton, and electron. Things didn't stop here. On further analyzing these subatomic particles, we found out that they are made up of quarks. Quarks are the fundamental part of anything that makes up the universe. They are called the elementary particles and can't be divided further. That brings us to the first fundamental force of the universe, the strong force. The strong force is responsible for holding the protons and neutrons together. It is called strong force for a reason. Since you might be knowing that the protons are positively charged, therefore it takes a strong force to keep all those positively charged particles together, because equal charges repel each other. Second fundamental force is the weak force. They are called weak forces because these forces act only in very small distance, about 0.1% of the diameter of a proton. Weak forces are responsible for radioactive decay, the forces which cause a proton to change into a neutron. Next force is the electromagnetic force, the force which is displayed by electrically charged particles and magnetic ones. Electricity and magnetism are the same things. Both follow the same principle, that the same type repels, and opposite type attracts. Also, you can create magnetism using electricity, and electricity using magnetism. The final fundamental force is the force of gravity, the reason why everything in the universe is grounded and stays where it is. Unlike all other forces, gravity is considered as a result of raps and curves in the space-time fabric. When a massive object is kept on the space-time fabric, it curves the space around it, thus causing less massive objects to revolve around it. Now physicists have been trying to find a unified theory to explain all the four fundamental forces of the universe. The theory of everything. So they came up with quantum field theory. As we know that within the hadrons, that is protons and neutrons, there are quarks, which is an elementary particle. These elementary particles are not visible, since in order to see something, we need light rays to fall on them and reflect back. But these particles are so small that the light waves miss them every time. If we observe them very hard, we can just see a blurry sphere of influence but not the particle themselves. So in order to study them, physicists came up with the concept of a point particle. They said every particle is a point of vibration in space. An electron is a point of vibration in space with certain electric charge and certain mass. This way physicists could define them and study their interactions. This theory came to be known as the quantum field theory, and had high accuracy in predicting behaviors of particles. But there was a huge problem with this theory: gravity. In quantum mechanics, all the physical forces are carried by certain particles. But according to Einstein's theory of relativity, gravity is nothing but warps and curves in space-time. It is not a force unlike others, it is geometry. the geometry of space-time, in which we need to describe the distances with absolute precision. But as we know in the quantum world, measuring anything precisely is not at all possible. So gravity doesn't fit in. Physicists tried to add gravity into the theory by introducing a virtual particle, graviton. But this introduction broke down the entire mathematics. So the quantum field theory isn't the theory of everything, until we somehow manage to explain gravity with quantum mechanics and standard model. So the physicists started thinking all over again, in the journey of finding a unified theory to explain them all. They knew that they needed more than a point to explain them. Maybe a line. Or a string. Thus string theory was developed, which holds the promise to unite them all. But that will be the next episode in this series, so stay tuned for that. In the meantime, you can check out other playlists of our channel by clicking on the link above. And if you liked the episode, hit the thumbs up button. Any suggestions and ideas for future episodes, please comment below. Subscribe, because we make videos every week, and press the bell icon to get notified. You can also connect with us on other social media platforms. All the links are provided below. Thank you for watching. Hope this video created a spark in your gray cells and helped you to understand the intricacies. We will meet again soon with another video. Till then, stay curious and keep learning.